This video presents and explains the benefits of Open BIM using real-life practical examples. Most of us are familiar with the main message of Open BIM: collaboration among disciplines, using open-source formats to exchange models and data. The IFC and BCF formats are well known. In this presentation, you will learn how Open BIM projects are shared among architects, engineers, builders, and clients. You will see how RIF architects save time and money by implementing the Open BIM collaboration workflow to design and build a high-end residential complex in Norway. A live Open BIM workflow demonstration will also be presented using Graphisoft ARCHICAD and BIMX, Tekla Structures, and BCF. We are presenting this demo on a real project, Rift Architects Residential Complex in Norway, in the heart of the Oslo Fjord, Sande. This project is known as Nordre Jarlsberg Brygge. The idyllic building complex, facing west, includes over 1,000 apartments, a hotel, kindergarten, restaurants, shops, and offices. ARCHICAD and Tekla Structures were originally used to create the project, but for this demo we've added MEP elements designed in DDS CAD MEP. The BIM concept presented in the following video consists of 3 models from the above-mentioned building complex. Here you can see a 3D view of the entire architectural project designed in ARCHICAD. The architectural, structural, and HVAC models are usually created by different teams of designers. The architectural model serves as a reference during Open BIM coordination. Now we will introduce the ARCHICAD features that support effective interdisciplinary collaboration. A good template file is essential. For all team members to be on the same page, the shared system must include identical project location settings, origin, north direction, and story structure. We also need to properly set up the following: element classification, structural function classification, position classification. Although most users know how to use a shared project location, let's take a quick look at it. The Project North setting is important. Reach this function at Options, Project Preferences, Set Project North. Define a typical point of the building as the project origin. In the future, share this point with the disciplines working in other softwares. During the design process, they should take care to place elements with respect to this project origin. For instance, this point can be a wall floor joint, so we just have to define the offset of the floor, marking the joint. To set story height, open the Story Settings dialog box, right-click on Stories in the Navigator project map. The architectural design must be shared in a way that meets the requirements of the receiving party. In our example, the receiving party is the structural engineers using Tekla Structures. For quick and fully automatic element filtering, all elements in the architectural model should have the appropriate element and load-bearing function classification. Open the Settings dialog of this slab. Let's check the slab's element classification in the Categories and Properties panel. An important aspect of element classification is element type. For instance, this slab was created using the ARCHICAD slab tool, so its default element type classification is set to slab, which is also a native IFC element property. However, the element type classification could also be set to ceiling if the slab were used to model suspended ceilings for a ceiling plan. Another important element classification is structural function. This slab can be classified as either load-bearing or non-load-bearing, depending on its current role in the design. The element classification settings have a direct effect on the content of the exported IFC file. The load-bearing properties of the elements represent a standard IFC property, interpreted accordingly by all IFC certified applications. The general practice is that structural function is defined by the structural engineer, but the architect can filter elements before exporting the project to make collaboration easier. For example, the ceiling panels and the furniture do not have to go out to the structural engineer in the IFC file. So the ARCHICAD project can be filtered to export load-bearing elements only. Elements can be listed and searched by their structural function, and the irrelevant non-load-bearing elements can be excluded from the file to be shared with our structural engineer. Therefore, although structural function is an ARCHICAD element property and is highly relevant for IFC export. Staying with the same example, we can classify the slab's position as well: exterior, interior, or undefined. Use this setting to filter by position, depending on what we want to share with the structural engineer consultant. This example shows the Find and Select tool using the position classification as a search criterion. Based on the position classification, we can quickly select the exterior wall elements and display them as the exterior envelope of a building. Now let's display the load-bearing elements only. Activate the Partial Structural Display option in ARCHICAD. The last option displays only the elements classified as load-bearing. For composite structures, too, only the load-bearing part will be displayed. By using the Filter and Cut elements in the 3D dialog, the window and door elements can also be hidden with only their nominal opening displayed. Structural engineers typically require this. To summarize, all elements in the architectural project model must be appropriately classified. This enables us to filter the architectural model and display only those elements that are necessary for the receiving party. In our case, only the structural load-bearing elements are displayed, and now we will export this in IFC file format for the structural engineers. ARCHICAD stores all project-related documentation of the building information model within a single project file. The navigator provides an overview and access to any part of the documentation. For example, browse among the floor plans, sections, and elevations. The content and graphical representation in each view depends on the architectural context. For example, architectural plans have completely different content and style of representation than the furniture plans. First, let's see an architectural plan. Then take a look at the furnishing plan. The Navigator View Map allows you to save and organize the different views of your BIM model in a fully customizable folder structure so that you can quickly access them at any time. The views of the Navigator View Map can be placed on sheets in the Layout book, then published via Publisher Set. We will take a closer look at publishing methods in the chapter on IFC export. Thus, the ARCHICAD project file stores not just the building model, but all the related documents, schedules, and lists. All these items can be managed easily with the Navigator. The graphic override function is a great way to provide model information at a glance. Graphic overrides apply a predefined appearance directly to model elements by view. For instance, you can highlight all elements having a specific acoustic rating. Let's see a simple example. We can use a graphic override to provide a schematic view of the model using only one material. To reach the options, go to Document, Graphic, Overrides Graphic, Override Combinations. In this model, all surfaces are overridden in white. Use the Graphic Override Rules dialog box to define the criteria for the override. Here, the criteria include all 3D element types. Set the override style by defining a pen color and surface override. Let's see another example. First, as discussed earlier, display only the load-bearing model elements. Use partial structure display. This time, highlight elements in different colors depending on their fire rating. Before applying a graphic override, all the elements' fire ratings must be specified. Ensure that the fire rating values are defined for each element at Element Settings, Categories, and Properties General Ratings, Fire Resistance Rating. Now go to the Graphic Override Combinations dialog. Create a new combination and name it Fire Resistance. Click Add to choose the rules to be applied. Fire resistance 1 hour, 1.5 hours, 2 hours, and undefined. Then click OK. Now all elements are colored according to their fire resistance rating. Model views can be made more informative and communicative with labels. All IFC properties assigned to elements in the current project and all IFC properties from imported IFC models can be displayed in floor plans, sections, elevations, and 3D views. The Label tool displays IFC properties by elements. Let's see a simple example. I'm going to use a 3D document view of a negative wall corner to represent building structures and the layers of the composite structures. At present, the Label tool is set to the text type, which displays only predefined text. As shown above, the Categories and Properties panel of Element Settings includes the IFC properties values. To display these values, we need to use a different label. In this example, the labels display IFC properties for each element. We can use the Categories and Properties Label 20 type to display any properties of the wall in any order. Right now, the element ID and 2 IFC properties, fire resistance rating and sound transmission, are included in the label. For another 2D label, I'm going to use the generic label 20 type. Here, the freely defined content gives you information about the size of the wall. For openings, the best choice is the door window stamp 20 type. It's simple to display the size, fire resistance rating, and sound transmission. In 3D documents or sections, displaying the layers of a composite structure can be useful. In this case, use the skin list label 20. The required structural layers are displayed instantly. To sum up, using the Label tool enhances the communication between the client and the contractor by making the plans more informative. The right label type and its content depend on the architectural context and the client. For example, labels with element size can be useful when sourcing building materials, while fire rating or acoustic ratings can be important when defining requirements or checking standard compliance. At any phase of the project, we can use interactive schedules to create schemes and lists of existing and imported elements. These schedules can be saved in spreadsheet format. For example, list the project's walls by quantity and fire rating. This schedule summarizes the major properties and quantities of walls having a particular fire rating schedule. It's refreshed automatically if any element is modified. Let's see another simple example, the zone list. Here, zones are grouped by story and listed with their zone area. This schedule provides the exact net areas of the building, which can be helpful in facility management. If the building's internal spaces are later redesigned, the existing zone list schedule can be easily edited to obtain the new area values. In the following, we introduce the most important export and import settings. Architects must be able to cooperate effectively with the other disciplines throughout the design process. Graphisoft's Open BIM workflow supports IFC-based data exchange. IFC data exchange enables communication among different software programs used in design, construction, and facility management, provided that those softwares are certified for IFC. This way, designers and other consultants are not constrained to use a particular tool. They can work and communicate using their own software. For data exchange to take place, each discipline should be able to easily extract the model information that must be communicated to the other partners. For example, displaying only the structural view can be helpful when exchanging data with the structural engineer. This 3D view is easy to produce. See the settings introduced in Section 4.2. In this case, only the load-bearing structure needs to be exported. For export, use the File Save As command and select the IFC compressed file extension. This format creates a compressed IFC zip file, which can be forwarded easily to the receiver. The selected translator contains options for optimized output. These options are introduced below. To narrow the set of exported elements, you can choose to export only the selected elements. For example, to export only the structural elements on a particular story. Use Find and Select to select this list of elements. Now use File, Save As, but this time choose Selected Elements only instead of Visible Elements. ARCHICAD provides several ways to export. Here we introduce the Publisher Set option. In the previous steps, we have already set up the 3D views for export based on their partial structure display. Now we will use the Publisher function to export 3 views. The first view is the architectural model, which is a complete architectural model. The second is the load-bearing model, which consists only of the load-bearing structure. The third is MEP export zones, which consist only of zone stamps in their category colors. Open the Organizer palette. We've already prepared a publisher set, entitled IFC Export, containing 3 views. We can choose an output format for each publisher item. This way, the exported content can be customized for the needs of the receiving party. ARCHICAD includes sets of factory-defined default IFC import and export options. These are called IFC translators. For example, to export 3D zone stamps to engineers who will design MEP systems using the DDS-CAD MEP program, choose the Data Exchange with DDS-CAD MEP translator. Choosing the right IFC translator optimizes data exchange between ARCHICAD and the receiver. To specify more detailed settings, you can use the IFC Translation Setup dialog box. In the Export Options panel, you can choose to export all the elements of the file, or just certain ones. The Building Information Data to Export setting may be significant. It includes the option to export all listed quantities and parameters. This setting is useful only if the receiver is using a software that can process this data. Next, we will look at how to import an IFC model into ARCHICAD. In ARCHICAD, we can decide whether to A. Open the IFC file as a new or a standalone project. B. Merge the IFC or parts of it to our existing project. Or C. Place a model as external reference into the existing project. Advantages of OpenIFC are: A. Before opening, we can check the settings of the IFC model by story. B. An IFC model opened as a .pln is independent of any other project. Or C. The imported file can be added to our project later as a hot-linked module. To open the IFC file as a standalone project, use the File Open command. As an example, Let's open the structural IFC model sent by the structural engineers. When we import a model from a non-native format, it must be converted to ARCHICAD. Under Translator, choose the default Data Exchange with Revit Structure predefined translator. This translator controls how we import the attributes and geometry of the IFC file into ARCHICAD. To check the detailed settings, click Settings to open the IFC Translator Setup dialog, and then Conversion Options to see what's defined. Here we can define the element types to be created during IFC conversion. The primary setting is the conversion of the building elements, which offers the following options: construction elements, otherwise morphs; construction elements, otherwise objects; morphs; objects. Our current import uses the construction elements option. Building elements of the IFC model convert into beams, columns, slabs, walls, or native ARCHICAD elements. The program is not able to display complex elements as native ARCHICAD elements. Such elements can be handled as either objects or morphs. With the construction elements, otherwise objects setting, every building element will appear as a native element except for complex objects, which will convert to objects. In contrast, the morph setting would convert all imported elements into morphs. The object setting would convert them into objects. There are advantages and disadvantages to each. Advantages of converting to morphs: no library parts are generated. Their intersections result in precise geometry. The imported elements do not generate new attributes. The 2D display projection can be controlled. The main disadvantage of converting to morphs: rendering of the 3D window becomes slower. Advantages of converting to objects: elements can be stored as library objects, which makes handling them easier. Their intersections result in precise geometry. The imported elements do not generate new attributes. The main disadvantage of converting to objects: their 2D projection is not always adequate and is laborsome to control. The distribution elements, the other elements, and the IFC site geometry settings also offer the options to choose other objects or morphs. Back in the Open dialog, click Open to continue. In the next pop-up window, click Link Library, select the appropriate folder, then click OK. The Embedded Library option is not recommended, especially in teamwork projects, because it creates numerous .gsm files, which can cause performance issues. In the next pop-up window, Model Filter for Import, choose the elements to import. In this case, we need all of them, so we leave all the boxes checked. Click OK. We can see that we have successfully opened the IFC file. Let's see it in 3D. By selecting parts of the model, we can verify how ARCHICAD has defined each element. For example, what was originally a slab now acts like a native ARCHICAD slab element. What was a steel column is now a column, and precast concrete panels are now objects. Let's take a closer look at a beam. We can see that most of the newly generated attributes include complex profiles. In this case, the conversion created a European Standard IPE 240 section beam. Now let's select a precast floor panel. We can see that because of the complexity of the panel, the element was converted as an object. Finally, let's save the file. This saved.pln will then be used as a hot-linked module in another project. We'll talk about them later. Now let's merge the IFC model to our own project. Advantages of the Merge IFC option are: the option to check the settings of the IFC model by story. We can add elements of the IFC model into our currently running project, which we can then edit in the same file. Its disadvantage is that it slows down teamwork projects. In Floor Plan View, let's go to File, Interoperability, Merge. Next, browse for the IFC file sent by the structural engineer. Let's select the appropriate IFC translator, in this case, Data Exchange with Tekla Structures. Click Settings to open IFC Translation Setup. In the Import Options panel, select the layer on which to place the imported elements. Our first option is to keep the original layer structure of the imported file. The second is to keep the original layers and add a user-defined extension to them. The third is to create a new layer for all the imported elements. Let's select the third option and create a new layer for the IFC file exported from Tekla. Choose Save Settings and Close, then click Open to complete the import process. Use hot-linked modules to place models from an external file into our current project. The advantages of hot links are that the linked module preserves its connection to the external file and can be updated without any modifications. A module can be refreshed if the source path of the external file has changed. We can place any number of module instances into the same file. Our project won't be slowed down by an IFC file opened directly in ARCHICAD, since it's an external module. The disadvantage is that we have to handle the two PLN files separately. To place a hot link, go to File, External Content, Place Hot Link Module. In the Choose Hot Link dialog, browse among the hot links already loaded into this project. If there aren't any hot links in the list, or we can't find the one we need, click New Hot Link and select the From File option. Browse for a file. Next, select the stories you need. In the case of a multi-story module, choose Multi-Story, then click OK. Place the module. When we place a multi-story module, the Match Stories dialog appears. In this dialog, select the current story. The module will be placed here. Click OK, then use Paste to place the module at its original location. To ensure that every model of the element appears correctly, the library belonging to the module must already be loaded into our project. Let's see the Placed Hot Linked module in the 3D window. Click on any element and try to edit it. We can see that the module element cannot be edited or moved in this file. But if something is changed in the source.pln file, we can refresh the placed module with the help of the Hot Link Manager. To do this, let's switch back to the floor plan view, then go to File, External Content, Hot Link Manager. If there was any sort of change in the Hot Link source file, the status displays an X instead of a check mark. In this case, we can click on the Update button to refresh the module. Now let's view the imported structural model. We see the architectural model displayed in a wireframe mode, and the Tekla structural elements appearing in different colors. We can toggle the wireframe display option in layer settings. We already have preset this. ARCHICAD generated new materials for the elements created in Tekla, which makes it easier to separate them from the architectural model. The structural model is displayed in both 2D and 3D views. Now let's zoom in on some details of the referenced structural model. We can clearly see that the slabs are made of concrete hollow core panels. The vertical structural elements are steel columns, etc. All the details are successfully imported and correctly positioned by ARCHICAD. Let's select an element. We can see the selected steel column is on the predefined Tekla layer. Let's go into the settings of the element and check its properties. In the Categories and Properties panel, we can see that ARCHICAD correctly classified the element as a column. Further down, under IFC Properties, we get information about the element's material type, section, etc., as defined by the structural engineer. If the structural model contains steel connections, such as bolts or joining plates, or if it contains elements, such as reinforcing mesh, starter bars, etc., we can display them too. This information is of great help to architects for detailed drawings. The imported IFC model can be displayed alongside the architectural model in 2D views, such as floor plans, sections, or elevations. To see the two models at the same time, we can use the trace and reference function. Let's create a section of our architectural model with a suitable layer combination, and then generate a new view from the same section with a different layer combination to display the structural model. To see the IFC model imported from Tekla aligned with our architectural model in the section, define the structural view as a trace reference. To do this, select the view in the view map, and right-click to choose Show as Trace Reference. Now the two views are displayed together. Enable the splitter function, and move the small arrow-shaped marker from the sides of the window to control the overlap of the two views at the same time. For example, displaying only the structural view on one side of the window. In this way, the trace and reference function allows us to manually check differences between the two models. True collaboration requires that the disciplines be able to manage a dynamically changing model. This means the back-and-forth flow of information must be continuous and fast. This requirement demands open cooperation and adherence to the agreed workflow by all parties, so that changes in new information reach every participant in a timely manner. Let's say some changes have happened in the structural model. In ARCHICAD, we can compare two versions of the same IFC model. To do this, enable the Detect IFC Model Changes function at File, Interoperability, IFC, Detect IFC Model Changes. Browse for the files to compare. It's important that the two IFC files being compared originate from a single application and a single project, because the comparison process is based upon the element's global ID numbers in the IFC model. If there are no identical IFC global IDs in the two versions, then all elements will be considered either new or deleted. Under Translator, select the option most suitable for the model, then click Next. Of course, we can define how to display the changes. For example, display only the changes made to the columns and slabs. Click Next. This list summarizes the detected changes by their type and quantity. To make it easier to manage the differences, the program will place the changed elements on different layers for each file version. Click Merge to activate the Markup tool. The Markup palette appears and collects the detected changes, then marks them with different colors depending on their category. Deleted elements have their own category, as do new elements and elements whose position or geometry has changed. In this case, the slabs and steel columns of the balconies have been altered. The red color indicates deleted elements. New ones are purple, and modified ones are green. We can now choose to accept or decline these modifications. With the help of the Markup tool, we can communicate with the other participants through ARCHICAD in both text and 3D. We use BCF, BIM Collaboration Format, for this purpose. BCF, BIM Collaboration Format, is an open file format which allows comments and screenshots to be attached to the IFC model, ensuring more effective communication between the parties. It's available only in programs which support BCF file format. 7.2. Sending a BCF message through ARCHICAD. Let's see an example of sending a BCF message. Suppose we need to change the size of a door opening, because it turns out we need a wider door. We have to notify the structural engineer, and the easiest way is by sending a BCF message. As a first step, navigate to the appropriate view showing the problematic area. Open the Markup Tools palette from the Documentation menu. Click Add Entry, and name the entry doors. Next, select the walls to be modified, and click Turn into Corrections to highlight them with the color. Click Capture to create a screenshot, then write the explanation text. Now export the selected message using the Import and Export Markup Entries option in BCF collaboration format. The walls to be modified have been saved with the BCF extension. Forward these to the structural engineer, who can easily handle this in Tekla BIM site. Naturally, ARCHICAD can also receive BCF files. We will look at an example of this in the next chapter. Use collision detection to identify clashes between the models of different disciplines. This process uses the BIM collaboration format to add comments to the problematic areas. Engineers can view these notes in their own models. Furthermore, you can save one or more collisions in a PDF file along with the comments. Therefore, clashes are instantly visible without using an additional program. In the following example, we will use Solibri to carry out collision detection. First, open the IFC models in Solibri. To do this, we navigate to File, Open Model. After opening a file, use the pop-up window to define the discipline for that file in the Discipline column. Load the models of the rest of the disciplines in the same way through the File, Add Models command. After loading all the models, go to the checking menu and select the category of collision rules. In our example, we want to examine collisions between the architectural model and the domestic water and sanitary systems of the MEP model. Select the architectural checking role, then select the MEP models and architectural model rule set from the next dialog box. Click on the check icon in the checking submenu to start collision detection. The program divides the collisions into several categories and lists them in the checking tree table. The program classifies the collisions according to the predefined rule set as critical, moderate, or low severity. Collisions, here called issues, can be expanded in the tree in the results view down to the element level. Click on an issue to show only the affected elements in the 3D model. We have the option to detect collisions according to the other rule sets as well. For example, checking the minimum distance between openings and elements of the MEP system. Use the Communication tab to create a presentation or slideshow of the issues found during the checking process. In the presentation file, we can organize the issues, add snapshots and comments, and set their properties. Once the presentation is prepared, generate a coordination report by clicking Report from the Presentation View toolbar. In this case, we save our report as a BCF file, so the engineers of other disciplines can open and comment on it with their own applications. In ARCHICAD, we open the BCF in the Markup tool. The BCF contains all the information previously added in Solibri. If we select a comment in the Markup Entries section of the palette, our 3D view zooms to the marked building element and highlights it. If we limit our 3D window with a cutting plane, for example, then we can see exactly why the element has been commented on. Graphisoft BIMX is an innovative, interactive BIM communication tool for designers, setting new standards for design communication and presentation. The Graphisoft BIMX and Graphisoft ARCHICAD applications enable architects, designers, clients, and facility managers to explore models in a 3D environment using familiar navigation techniques. Graphisoft BIMX provides an easy-to-use and fun way to discover 3D architectural models. Clients can enjoy a professional 3D presentation in a free viewer application without the need to install any professional software. There are two ways to save the BIMX hypermodel: through the ARCHICAD File menu and through the Publisher set. We are now exporting through the ARCHICAD File menu, but we have already created a publishing set before. After the completion of the 3D model and 2D documentations of the project, go to File, Publish BIMX Hypermodel. We need to use the 3D window to export. In the pop-up dialog, we chose the BIMX option in the Set to Publish drop-down menu. This option appears if you have previously created a BIMX model for export using a publisher set. In the Publishing Properties settings, we have already specified the publishing method. and we have to set the location to export to. Then we added the 3D view of our model called Architectural Model to the set. So in this dialog, you can see the views that we have created in the Publisher set list. Select the Architectural Model view and click the Publish button to export. After exporting, you can view the BIMX model with BIMX Desktop Viewer or open it on an iPad or other mobile devices. With BIMX for BIM Data Access, our award-winning mobile application, even non-professionals can easily access and view the BIM models which were created by ARCHICAD. BIMX is a great presentation tool which you can download for free from the Apple App Store or from Google Play. To present an example, let's open the file in the BIMX Desktop Viewer. Presenting and exploring the BIM model is simple. Navigate in the model with the control keys, like in a computer game. A further advantage of BIMX is that you can store and review not only the 3D model, but also the entire construction documentation at any time. Thus, the contractor can walk through the construction site and check the documents on an iPad without needing the actual paper documents. Thank you very much for taking the time to find out more about OpenBIM.